Hello friends, in the previous lecture we studied about how to calculate resistance for some given cases. Today we will be continuing with them. Let's say I have a cylinder, and this cylinder, let's say, is a hollow cylinder with the internal radius. The internal radius is, let's say, A, and the external radius is B. If current is entering from one side and exiting from in the other direction, in that case, if it is given that the resistivity of the material is rho, then find the resistance of this circuit, of this conductor. Now, how to find the resistance? So resistance is given by rho L by A. Rho is resistivity, which is uniform everywhere. Length. Now, if the length of the tube was given to be, of the pipe was given to be L, the radii were small a and small b. In this case, the resistance becomes rho L is L, because L is the length of the conductor in the direction in which the current is flowing. So L is L, and the area is actually this area of cross section. Okay, and what is that area? This area is given by pi into b square minus a square. Pi b square minus pi a square. So that is pi b square minus a square. This is the value of this resistance. This is a pretty simple question, but a little more difficult question would be if the current was actually flowing radially outwards. In this particular question, the current is actually flowing along the axis. It is flowing axially. What if the current is flowing radially outwards? Now, if the current is flowing radially outwards, in that case, if I look at the cross section, if I look at this from this side, what would I see? I would observe that there is a large circle and a smaller circle. This is the inner radius and this is the outer radius. The inner radius is A and the outer radius is B. And if the current is actually flowing outwards, that is radially outwards, in that case, now I again need to find out the resistance. This is the second question. The same cylinder, but the current is flowing outwards. Now, if I need to find out the current, what would I do? I would actually, now here, if I simply apply resistance is equal to rho L by A, then rho is the resistivity, that is uniform everywhere. But when we talk about L is the length which is measured along the direction of flow of current. Now the direction of flow of current is outwards. So okay, length, you may say that the length is B minus A, this length. Okay, so the length is B minus A. But what about area? Now area is always measured perpendicular to the direction of flow of current. The direction of flow of current was like this. So in the previous question, we measured this area. But here, the area is outwards. Now, which area would you take? The inner area or the outer area? Or average? No. Actually, that is not the case. In this particular case, we need to integrate. How do we integrate? All we do is, we take an element. We take an element whose radius is R and whose width is dr. And I first try and calculate the radius of this cylindrical shell. Okay, so the small resistance of that area is given by rho. What is L? L is the direction, L is the length of the element measured in the direction of current. And as the direction of current is outwards, so in that direction the length is dr. dr is the length of that element, dl. Okay, rho L, this is rho, this is L by A. And what is the area of cross section? Now if the current is going outwards from everywhere, the area of cross section would be the curved area of the cylinder. So the curved area of cylinder is given by pi 2 pi r into L, because L is the length, 2 pi r L, the curved area of a cylinder. I hope you remember the formula for the curved surface area of a cylinder. It is 2 pi r into the length, 2 pi r L. Okay, so rho dr upon 2 pi r L. This is the resistance of one of this red element. Now, if I need to find out the resultant, how many such elements are there? There are infinite such elements. Why? Because there is one element, okay, one shell, then there is another shell, then there is another shell, then there is another shell. There are a lot of shells. And the best part is the current which enters in one shell also goes to the other shell, also goes to the other shell. That means for all the shells, current is the thing which is constant. And if current is same for all the shells, that means this combination is in series or parallel. If current is constant, that means the combination is in series. And if it is in series, in that case, to find out the net resultant, what we need is, we simply need to add them up. The resistance goes from 0 to R, and the radius goes from A to B. So this comes out to be, R comes out to be rho by 2 pi L into, what is the integral A to B 1 by R dr. Now what is the integral of 1 by R? The integral of 1 by R is ln R. So rho by 2 pi L into ln, or when I apply limits, it is ln B by A. So this is the expression for resistance in this case. Now if the current was flowing axially, then resistance was given by this expression. And if the current is flowing radially outwards, in that case the current is given by this expression. Okay? Now, if I come to another question like this, let's say this was a cylinder. Okay, this was a cylinder. This is what it looked when I looked this cylinder from this side. Okay, so the current was going in radially outward direction in a hollow cylinder. What if current flows in a radially outward direction in a hollow sphere? Let's say there is a hollow sphere. The internal radius is A and the outer radius is B, and the current flows outwards. Okay, let's say the resistivity is given to be rho. Now can you try and find out the resistance? The net resistance can be calculated only once you imagine or assume a very small element, and that element would be a concentric spherical shell. That concentric spherical shell would have a radius small r and a width dr. What is the very small radius, very small resistance of this shell? So it is given by rho. What is the length of the shell measured in the direction of flow of current? The direction of flow of current is actually outwards. I hope you understood that. The current is flowing outwards. So the current is flowing outwards, then what is the direction of current in the direction, what is the width of element in the direction of current? It is dr, rho into dr upon area. And what is the area? Now if the current is going outwards in all directions, then the area of cross section is the area of the curved area of the sphere. And what is the curved area of this sphere? It is 4 pi r square. And as all the shells are one after the other, the current which passes through one shell goes through the other shell, goes through the other shell, and so on. And that means all the shells are in series. If all of them are in series, we simply add them up or we integrate them. Resistance goes from 0 to R, and radius goes from A to B. So R becomes rho upon 4 pi 1 by r square dr integral A to B. Now what is the integral of 1 by r square? It is minus 1 by r. So this becomes rho upon 4 pi, and when I apply limits, this becomes rho upon 4 pi, and the integral becomes 1 upon A minus 1 upon B. This is the resistance for a spherical conductor, hollow spherical conductor, when the current is flowing from in the radial direction. Okay, so please note these two things down. Now, once we have studied how to calculate resistance for different shapes of conductors, now we can talk about the next topic, which is resistances in circuit. Resistance in circuits. Now, look at this very closely. Basically, if I have a resistance here inside a circuit, and the resistance is given by R. Okay. Now, if there is a current flowing in this direction, in that case, we know that V is equal to IR. Now, current flows in the direction of higher potential to lower potential in a resistance. That means if I am saying that current is flowing in this direction, and that simply means that this potential must be higher and this potential must be lower. Okay, so always keep this thing in mind. The current flows in a resistance in a direction so that it flows from higher potential to lower potential. Current flows from higher potential in resistance to lower potential in resistance. These plus and minus signs are actually indicating that the potential at this point is higher from this one as compared to this one, and the minus sign indicates that the potential is lower as compared to this one. Okay, and the potential difference V, if the potential difference is V, then this V is given by IR. Okay, now if I talk about what is the energy consumed, what I would say is that what is potential? Potential is the change in energy, or change in potential is the change in energy per unit charge. Okay, that means that if a unit charge, 1 coulomb of charge goes from this point to this point, its energy gets reduced by V. Okay, so if the change in energy is given by V multiplied by Q. If a unit charge goes from this point to this point, the loss in energy is, the loss in electrical energy is V. If Q charge goes from this point to this point, the loss is Q into V. But if I ask you what is the rate at which energy is being lost, so in that case I would differentiate this, and what I would write is the power rate of loss of energy is given by V multiplied by, and as V is constant, so V comes out of the derivative, and the derivative of Q becomes I. Okay, so the power is given by V into I. I can actually put in the values of V and I from this expression. If I put in the value of V as IR, so power also becomes I square R. And if I put in the value of I as V by R here, so the power also becomes V square by R. Okay, so what I mean to say is that when a resistance is there and a current I flows through it, the rate at which the energy is being lost is given by I square R, or V square by R, or VI.